Hi, my name is Carter Tobby, and this is my analysis of the water quality in the Cedar Creek watershed, which encompasses parts of Noble County, Allen County, and DeKalb County, based on a 2012 survey performed by Professor Palladino and a group of graduate students. Starting off with some background, just glossing over a couple fishing spots and outdoor opportunities. So on Shoaf Road, about 10 to 15 minutes north of Fort Wayne, there is an access point in which you can paddle a quarter-mile upstream to a low-head dam, which offers excellent fishing opportunities. And there's also a starting point and a stopping point for a scenic float trip on Tonkel Road down to Highway 1 in Leo. There are many other small parks, but one that's notable is Matea County Park. That's very close to Fort Wayne. It's about 20 minutes away from PFW, and that offers a set of trail systems that run along the river, and it's a beautiful little nook right outside of Fort Wayne. But if you don't like being outside and you still want a reason to listen to this presentation, then the Cedar Creek flows from the northwest down into the St. Joseph River, which goes into the city of Fort Wayne and is used for drinking water in the city. Now, on the St. Joseph River, there are 49 different USGS gauging stations, in the St. Joseph River watershed, so that encompasses the Cedar Creek watershed as well. And of those 49 in the total watershed, 20 of them are within the Cedar Creek watershed. So that just shows you how big of a headwater the Cedar Creek is for the St. Joseph River. And looking even bigger in picture than that, if you don't already know, the St. Joseph River flows into Fort Wayne and meets with the St. Mary and then goes into the Maumee and into Lake Erie. And that'll come to be more important when we talk about phosphorus. So moving on to the background of this paper or presentation. That would be the Watershed Reliability, Resistance, and Vulnerability Analysis under uncertainty using water quality data by Yaman Hoke, Shivan Tripathi, Mohammed Hattush, Rao Goffindro, and Professor Palladino. In this survey, they were trying to test a new form of quantifying the data instead of actually testing and trying to look for solutions for the water quality. The data within the survey is still valid for water quality, so I'm going to use it in analyzing the data alone, along with giving a short explanation for how they did it and why they need to come up with a formula to quantify the data instead of just taking the data directly. For that, we have to figure out what water quality affects. So water quality impacts two things. It affects people and aquatic organisms. On the people side, we are mostly affected by the herbicides that go into the water through runoff, and that would be allichlor and atrazine in this survey. And then the aquatic organisms are more affected by ammonia and phosphorus. You can see here I included a table which shows the limits for the total concentration of each substance in the water as set by the US government. And moving on to allichlor and atrazine. So, as stated previously, they are both herbicides and they're transported through the Cedar Creek through tile and from runoff from large storms. And this is especially bad when the farmers fertilize and then a large storm happens within a couple of days of that fertilization, because the fertilizer and minerals do not have a time to seep into the soil and they just instantly run off into the drainage ditches, which flow directly into the Cedar Creek. Another thing about tile is, if you don't know, tile is just plastic tubing that they actually bury beneath the soil so that water can flow directly into it unimpeded and into the ditches. So that is just a super highway for all these herbicides and bad things to get put into our waterways around agricultural areas. So reading these tables, you can see the observed data point is a single dot and they're mostly scattered around here. The load estimated is what was used previously for calculating the data. So that actually takes data and manufactures data points where they could not get a reading. So as I was saying previously with those USGS monitoring stations, you have to know the stream, like the current flow, because the amount of minerals going down through the water depends on the speed of the water. If the water is moving faster, then more minerals and more pollutants are being passed through there and into the St. Joseph River and into Lake Erie. So that data is extremely important, but those values are also very hard to come across. So they actually developed this RVM, which is the relevance vector machine, which accounts for errors in the predicted data amounts by finding the data points and then extrapolating from those data points and accounting for error in the extrapolated points. So in the predicted points, they actually account for error, and they did not do that with the previous load estimated model. So that is why this study was so important in, treading way for making a new system. But moving on with reading the chart, the blue dotted line is just the standard, so that's the threshold we were talking about in those tables I showed. So that's the top amount that should not be exceeded in the creek. And the gray little area is the lower 5% and the higher 95% of the reading. So if you're familiar with the normal model, so the bell curve, those little outsides that are just outliers that really don't affect the data or shouldn't affect the data points but are notable. So looking at allichlor levels, you can see the allichlor was low. It did not exceed any of the threshold points at any time. It got close, but especially that red RVM line stayed beneath the threshold, so Cedar Creek is at a healthy level for allichlor levels. Moving on to atrazine, you can see that the Cedar Creek is also at a healthy level, although it did come close at some times. With those estimated points and with the uncertainty of the data, the proctors of the test still found that the Cedar Creek was at a healthy level for atrazine. Ammonia. So ammonia isn't bad for people in the water. It's bad for the animals. And this is a direct quote from McDaniel, and he says, ammonia has been found to reduce dissolved oxygen levels, impair fish growth and development, cause disease in fish, and can be toxic at higher pH levels. So that's just a general fact about ammonia, that in large amounts it is not good, but in small amounts is actually needed for fish growth. So it has to be in that perfect set. Also about ammonia is these sculpin here, you can see, they are an excellent tell for if the water quality in a river is healthy, because they're especially sensitive to changes in ammonia, and they prefer these other habitational characteristics, but mostly the ammonia. And a fun fact about the Cedar Creek, when I was a child, we fished all the time with nets and we would catch these sculpin everywhere. Now, in 2018, when I started fishing the Cedar Creek again, I never caught one except for one of my buddies did end up catching one late December one year in 2018. So they are in Cedar Creek, which is a tell for a lower ammonia or a healthy ammonia content in the river. And which, going along with that, you can see that the RVM line, the red line, does not even come close to the threshold amount for ammonia in the water. That's excellent. Phosphorus. So phosphorus is what causes giant algal blooms. Phosphorus is needed in the ecosystem, but in great amounts it can be detrimental because the algae can grow way too rapidly and consume all the oxygen in the water. Then when it dies off, it is terrible for the entire ecosystem. But phosphorus is actually never found in nature in its pure form. So the phosphorus recorded in this study was in another chemical in a fertilizer, and it actually did come close to the threshold amounts quite a few times, although with the RVM graph it was still deemed a healthy river. So keep that in mind, that phosphorus levels were high. So there are toxic algae too. So blue-green algae is a toxic algae that causes rashes on humans and can be worse. So keep that in mind when visiting the Cedar Creek, that phosphorus levels are high. So if you see any algae that looks nasty or smells nasty, don't touch it. Some closing words. The Cedar Creek is below the threshold for all constituents. So that means that the Cedar Creek is a healthy watershed. You can visit the Cedar Creek. The Cedar Creek is beautiful, and thank you. If you have any questions, contact me at my email. In case you didn't find solace in the data that I had in those other charts, I took the time to look at other studies done in the Cedar Creek. This one was for a type of beetle, and they had water quality measurements in it. So these numbers actually correlate well with the numbers in the study that I used, and I included another table that you can see here, which was about crawdad population.